This is code.org, and this is an incredibly awesome racing game, ta-da, that I built. And I am going to walk you through how to build your own. First, let me show off what it does because it's awesome. Okay, I'm going to hit run. Oh yeah, here's my start screen, code race, code, and start. Ah. Oh, I don't want to hit. So I got a point because I missed them. Ooh, cakes give me double bonus. Ooh, I missed, da-da-da-da-da. Cake, no. They get coming fast, and it can be. And I lost a point there because I was hit. So you get the picture. Ooh, we're getting so many cakes. This is, I think, lucky for me. Woohoo! Hey, I've been doing all right. I think you get the point of it, right? And we can mess with speed and things like that. And here, I'll just give it one more run through. There's a lot of different things we're controlling for. The tree speed, the items, the object speed, my player speed, which I sped up just before I started this video because I'm so bad at see, now I'm in the negatives. But it is fairly straightforward to make all this happen. And so I'm going to walk you through it so you can build your own racing game or your own better racing game. And make sure to post it below in the comments. The code for this and the game are posted in the description. So check out the game. It's in the description. Check out the code. Take a look at it. This would meet all of the requirements for an AP performance task if you're looking for ideas for that. Obviously, make sure to build your own stuff. Plagiarism's plagiarism. All right, that being said, let's take a look. So starting right off the bat, I have, well, my global variables. And what they are is my player's X location, my move left is at 0, and my move right's at 0 because I don't want to move left or right when we start. Score is going to be set at 0, and then side speed. Side speed is how fast my player is going left to right. Award point true, we'll get to that in just a sec. And then the car step size is, I wonder, oh no, I will get to that as well. It's something slightly different and I'll explain when we're there. Obstacles. So this is, you notice that there was a bus and then there was a taxi and a car and a birthday cake. And that's where this comes from, this list right here. So now let's get to the functions. On the event that I click the start button, let's set the game screen, and run the main function. And here's main right here. Let's start going through main, and keep in mind, I have this on the event that I click the left arrow key or the right arrow key, and what do? There's our car step size, and then we move right, and we make it equal to whatever our car step size is. I'll show you why that is in a sec. All right, so let's first go through main. Variable tree y, so this is going to be our tree's y location. Y is going to be set, is going to set to 165, and then the object's Y location is also 165. So that's just for this tree and that tree, because we're going to be controlling it as we move on. It's going to be changing. So then we get to our time loop. We're going to run this time loop every 10 milliseconds. So keep in mind there is 1,000 milliseconds in a second. So we are running this constantly. All right, so the tree Y is going to move, and that's why it looks like a smooth movement. Because what I'm doing here is tree Y equals move tree, and then I use tree Y as a parameter, so I'm passing it. So right when I start, tree Y was equal to what? 165. So this is 165. So let's go find the function move tree, and remember tree Y is going to be 165 right now. So function move tree Y think 165. 165, or tree Y, is going to be equal, because now we're giving tree Y a new value. Tree Y is now equal to tree Y what it used to be, so 165 plus 0.5. So that'd be 165.5. Variable random equals 460 to 800. And what that is controlling for is when the tree regenerates. So over 460, it is off the screen. I'm just kind of randomizing how often it's going to plot back up here, right? Because then I say as long as tree Y is less than random or greater than random, as long as tree Y is greater than random, then and now I'm using another random number here, what this is 1 or 2 is the sides. So if it's equal to 1, I'm going to generate a number between -40 and -5, which is going to set our tree somewhere in between here. Or if it's not equal to 1, I automatically will set it on the other side. And then I set the new tree, so I set the position of tree, and I use random for the X, and 145 for the y, which is not what I want. Oh no, that is. Okay. Just kidding. Random for the x and 145 for the y. And then tree y is now going to be 145, like I was just saying. All right, there we are. And then once we're done with this, we return tree y, which is going to set us back up into main. Okay? And then I might as well make sure this all agrees. So now that we're back up into main, tree y is going to be equal to what we just returned. Okay? We're only going to, if tree y is greater than random, so only if the tree is off the screen are we going to reset the tree's y value to 145. Otherwise, we're just adding 0.5 to it each time. Okay? So now we have tree would now be equal to 145.5 because it was not yet off the screen. And this is important because this is exactly how our objects worked. Object, move object, object y. The speed's a bit different. It's why it gets its own function, but observe. So object y, and object y is going to be equal to what? Well, object y starts at 165y. So object y is going to be equal to 165. So object y is 165, move object. Object y plus plus. Two pluses just mean add one. So that means object y was 165. Object y is now 166. So 166, okay? Set object y value to object y. So we just added 1 to the object y value, and so I'm setting it right away. It's going to move 1 pixel down the screen, which sounds like nothing. But again, this main function that's calling these other functions is going to be running, the stuff in this time loop is going to be running every 10 milliseconds, right? And there's 1,000 seconds in a millisecond. So a lot. All right, so now we updated that. And then if our object is greater than 460, meaning if my bus here is off the screen or whatever item has been randomized here, if it is off the screen, what do I want to do? Oh, I want to set the object x to a random number between 40 and 200. Well, if you notice, 40 and 200 is somewhere on the road is what I'm saying there. Okay, so 40, 200, right over here somewhere. We want it on the road. I could even extend this to like 210. So, and then once I set that up, once I decide that's the new x value, I'm going to set the object y value back to what it was before. And what was it before? 160, 165. And then I'm going to switch award point equal to true. Why I am doing this is because when we do award a point, we use this in the if statement. So let's actually, while object plus plus, move object. Where do I check for that? Oh, I'm going to do a check for collision. Okay. So award point equals true means, the reason I'm doing this here is it means I know my object's regenerated and you can award a point again. And you'll see that more in a second. This randomizes color, so red, green, blue are my variables. Set object icon color red, green, blue, right? And the RGB values are 0 to 255, 255 being max. So if this was 0 and this was 0, 255 here would be a completely red object. So this is going to just randomize the color. 1 means I want it not transparent at all. Set property object image. This randomizes the obstacles image, right? So it could either be a bus, a taxi, a car, or birthday cake. And if you're wondering where I'm getting these, if I click on this and click choose, all of these icons is what I used. So this is that. And that's where I got these from. All right. move object. So we randomize the image, and then we're going to set I want to make sure that the width and height are what I want them to be. Else, if object y is greater than, so if object y is not greater than 260, so if it's not greater than 260, now I'm going to ask the computer, well, is it greater than 370? Okay, because if it's greater than 370 and award point equals true, I'll explain that in just a sec, add 1 to score. Set property, score text 1 point, award point now equals false. And that's where it is. So the reason I use award point, I'm checking if award point's true here, right, with the to equality operator. And then with an assignment operator, an equal sign here, I make award point equal to false, is because I don't want the computer to give me a point for every 1/10 of a millisecond the car or the object I passed is below me. It should only give me a point once. That once it's down here, I should be getting a point, but not for every millisecond that it is down here. And that's why I'm using award point, because once I get that point after having passed the other object, I set that equal to false, and if it's equal to false, I don't let myself, or I don't let the player get another point up until that object is greater than, the object's y is greater than 460, and it's been respawned at the top. Then I set award point equal to true again, and if award point equals true, and the object is greater than 370 below my car, then I can get a point again. So that's how that's used. All right, now let's talk player movement. While I'm running this, so when I click move left or move right, it doesn't actually do something immediately. Well, it does. Move right's going to be equal to car step size. And this was just so I could control it easily. I could put 30 and 30 down here, but regardless, 30 for car step size, and this is move right and move left. So what I'm going to be doing then is once a player has done that, car step size would equal, so let's say I click on the left arrow key, then move left equals 30. I'm going to get down here, move player, so my variable move left is going to be set to equal move player, move left, right? So whatever my left value is, and I just said it would be 30, these are my parameters, side speed times -1. My side speed is 1.5, so I'm going to move over at 1.5 pixels per second, I believe. Well, not per second, but all right, move left, and then my speed, side speed times -1, so that's just going to be -1.5. So move player, 30, -1.5 for speed. Now let me go find move player, and here's my move player function. And here's my move player function. And so remember, direction was 30, car speed was -1.5. So if direction doesn't equal 0, set player x, or set property of player x to player x. I then say player x equals player x plus car speed. So I'm adding car speed to this, whatever that was, right? Whatever that was. And then I'm taking direction, and I guess I should call this step instead, because I'm moving to the left or to the right. Yeah, we'll call it step. And I'm taking that, so I'm adding or subtracting to the player's x value. Since I'm going left, I'm taking away -1 each time, because car speed, remember, was set to be -1. Then I'm taking 1 away from step, right? Because minus means to subtract 1 from whatever step is. Step was the move left thing. Then I return step. What do I mean when I say I return step? Well, when I go back up here, move left now equals whatever step was after we ran through this, right? And so what step would be after I run through this, if move left was 30, step was 30, step is minus, so move left -1 is 29. So they would return 29 and move left would now be 29. It's the same process for move right, but move right and side speed is not multiplied by a -1 because I want to go over it that way. The final function that's going to run for this is collision object. And let's go find that. Here we are. So collision, check collision obstacle. And what we're going to be doing with this, yep, check collision obstacle. So here's our obstacle, if award point equals true. So first thing I want to do is check if the award point is true. Because if I'm still accepting an award point, and I've run into this car, I want to subtract a point, right? So I know I haven't passed the car yet, and I want to make sure that if award point is true, all right, because if award point's not true, that means the car is now beneath us anyways, or we've run into it. So regardless, right, if it's touching me for all of this, I don't want it to keep subtracting points for every millisecond it's touching me. So same deal here. If award point's equal to true, then car center, so this is the center of my car roughly, 315, because you have to remember with images, it's the top left corner that you are setting it to. So this car is set to like 121, 271, but that's not helpful when trying to detect if two things are hitting each other. So I find the center of each of them, and that's what this is roughly. My car is centered X at roughly 315. Oh, centered Y at 315. Oh yeah, that makes sense, of course. And centered X at, well, player X plus 40. And I do player X plus 40 because the width of my car is 80. So I say that's roughly the center since it's going to be the top corner. Okay, and so that's that. And then the center of my obstacle, well, I get my obstacle's Y value, right? So the center obstacle Y equals get obstacle Y. Okay. And then once I have that Y value, I'm going to say center of obstacle Y equals center of obstacle Y, get property obstacle height divide by 2. So I'm getting the height of my obstacle, which I think is 70, dividing it by 2, so I get 35, and adding it to the current Y location of my obstacle. So that will be roughly the center Y for my obstacle. Then get property obstacle X for the center of obstacle X. Same thing with obstacle X now. I get the property for the width, divide by 2, and add it. So I should, with all of that, get the center of my obstacle and the center of my car. And now, if math absolute value means it's not negative or positive, well, it doesn't matter. So the absolute value of 10 minus 100 is not negative 90, it is 90. The absolute value of 10 minus 100 is 90. Or the absolute value of 100 minus 10 is 90. It just gets rid of the negative. So that's what this is, math.absolute value, because I don't care if my car location, if the center of my car is further left or further right than my bus here, right? I don't care if it's on the negative side. If they're close enough that they could be touching, that's what I care about. So if the center of my car minus the center of my obstacle's Y value is less than 40, so if they're close, then I check, okay, if the center of my car's X value is less than 40 minus the center of my obstacle's X value, absolute value, is less than 50, then I want to change colors. So I again use variables for random numbers. I then set the property player icon, right? Yep. So I set the color again like I did up there. I changed the color. If get property object image equals birthday cake, because the birthday cake is a special object where you're rewarded 2 points. So if the item is a birthday cake, score equals score plus 2. Else, so if it's any other obstacle, subtract 1 from score. Then I set award points to false because I don't want to award points at the bottom of the screen when the object they hit gets to the bottom, or the object that they successfully got, like the birthday cake. And then I reset the score, set property, text, and score. And that should get us through. Oh, yep, I almost caused an error there. I'm just going to copy and paste. Ta-da! So it is a bunch of code. It is pretty fun though. You should definitely test it out yourself. Like I said, I'll post it in the description. I gotta play one more game. Oh no, I'm gonna start off negative. Oh no, I want a cake. You like those trees effect? That's not where I wanted. I didn't want to go that way. That wasn't fair. It wasn't my fault. Oh, I'm getting lots of cakes. I'm not as good at this as I should be. I've been testing it a lot in my... No! Okay, well, I tried. Anyways, you should make something awesome. You should play this a bit, get some ideas, look at the code, remix it, make something awesome, make something so much better, and post it in the comments below. And I'm excited to play it and see what y'all create.